But you get this text this morning, it says, that first thing, it says, good morning, folks. The sunspot number has risen to 139. The solar flux index has risen to 157. Yesterday, sunspot 4168 erupted, producing an M4.45 solar flare with a partial CME. The CME could graze the Earth on August the 8th, causing a possible G1 class geomagnetic storm on August the 8th. Chance of flares today, 50% for M class, 10% for X class. Now, a lot of people, including me, when he first started sending this out, I went, what the heck is that? So I'm going, Russ built me this because Russ had to be out of town tonight, or Russ would have presented. He is a great presenter, and he knows this stuff upside and down. So, if you've got the chat, you get that every morning, but what does it mean and why is it important to HF Radio? Well, what is sent out each morning is a very basic snapshot, and that is true. It is a very basic snapshot of what the solar activity is. It gives you a quick idea of how the HF bands are going to behave that day. And it could impact your plans to participate on the radio that day. So what's the rule for HF guys? You don't care what that chart says. What are you going to? How do you really know whether the HF bands are working that day?
When you talk on them,
huh? On there. Trial and error. You get on there and you throw your call sign out, and if nobody comes back to you, it's a bad day. So, but that's how. I mean, because I've read this thing and I've looked at that and I'm going, man, this is not going to be a good day to even go out there and hook that antenna up. But I go out there and hook the antenna up, and I'll be doggone. There's traffic jams on 20 meters. So, yes, they give you reliable information, but
before you change it, be kind enough to tell me what is an M class or an X class. I don't have a clue.
We're going to.
Okay.
You're going to get a little bit of a clue here in just a few minutes. Thanks the sunspot number. The number of sunspots until it don't affect radio signals. But the higher the number, the more solar. So the higher the number, the more fish there is for you to catch. It's just that simple. If you think about a room, if we were all to start talking to here, sooner or later, it would create quite a bit of noise. That's the same with the sunspot numbers. But that number is more solar. But then we've got to have the solar index along with the rated sunspot number. Now, I was trying to find it, talking about the sunspots. One of the guys that I was listening to today or yesterday on the trying to prepare for this, he was talking about, he goes, the thing that you are missing from the sunspot number, I never thought of this. He goes, you're probably only getting at best about 60%. Because at any given time, you can't see the other side of the sun. So you're only seeing about 60% of maybe what's out there as sunspots on the Earth, on the sun. So also provided in that is the solar flux index, along with the sunspot number. It's another indicator of solar activity. The flux SFI is daily measured. The sun's radio emissions. Did you get that? What's that say? How many of you know that the sun transmitted? The sun's radio emissions at a wavelength of 2,800 megahertz. Now, they knew this about 400 years ago, that there was something coming out of it was before radio. But when, does anybody have any idea when this became extremely noticeable?
Telegraph came out.
World War II. In World War II, when they were trying to do ocean over radar, some of the radars that were operating on 3,200, they were getting more and more and more interference. And they couldn't figure out what it was. Well, it was this 2,800 megahertz that was interfering with their radar. So I thought that was pretty interesting. That out of World War II gave us yet another thing that we found out about radio, which is pretty cool. in this daily report, this is your most important number. The solar flux index is your most important number. Why is it so important? Well, because it's a direct indicator of solar activity that affects your propagation. Now, Gary's over there, he's dissecting this, right? Because Gary's a great guy, he's an engineer. So he's dissecting this, going, is he right so far, Gary? He's on the money. All right. Where in the Earth's ionosphere? Now, when you took all 3 level tests, you saw that word a lot. Ionosphere, ionosphere, ionosphere. What's so important about the ionosphere as far as radio signal goes?
D, E, F1, F2.
Daytime.
At nighttime.
What's missing at night?
The D layer.
The D layer goes missing at night. Why? Can't hold those particles anymore, so it disappears. Something else happens at night with the F.
They combine. F1 and
combine,
F2 typically combine.
It typically combines. So you go to 2. So that those layers that we've heard about, all this testing that we've taken, come into play here. But that word propagation affects the radio wave propagation is the higher the SFI value means the greater solar emissions. Where'd they come from? Where'd the solar emissions come from? Sun what? The sun's spots. Okay. So you got that radioactive shot coming down, and it gets grabbed by the layers, and one layer in particular, especially during the daytime. And a lot of people use the wrong word, starts with an R. When you send that signal up, it reflects. It does not. It refracts. Our resident physicist in the back here, literally, will keep us straight.
I was saying, Mike, you should say some spots are good.
Some spots are good. Yeah, some spots are good. Unless
More sunspots, better.
Unless you get some problem with it. And we're going to talk about that in just a minute. But it increases the ionization of the F2 layer of the ionosphere. These great big words. The higher the ionization improves the maximum usable MUP. Anybody remember that word on their test?
Yeah.
MUP, maximal usable frequency. Now, a phenomenon can occur to where there's so much up there that the maximal usable frequency is higher than the lowest usable frequency. And you know what you do when you find that? You turn to the off button. You go ahead and find something else to do, because there's not much propagation going to be going on. But 20 meters, the band that likes both of those, it likes the night and it likes the day. 40 meters, allegedly, doesn't like the daytime so much. Sometimes it does, but it's like night and day. If you switch between 20 meters and 40 meters in the daytime, you can definitely tell there's some difference in those two bands. And I'm not a big HF guy. I'll be honest with you. I'm not a big HF guy. I've got an antenna in my, it's funny. We had a guy, I need to get pictures of him and just figure out how to get these on there, but we had a guy donate some stuff to the club. Well, it was in great disrepair. But he had a vertical antenna that had been in his yard for probably 20 years. So when I started looking at it, the coax was all deteriorated, come down, the jumpers go in between, or it's not the correct name for UHF vertical guys. What is it? The trap lines that go from one antenna segment to the other are all bashed up. So I've rebuilt it, and I've got it actually temporarily installed on my trailer. It had an ugly balun. Anybody had it halfway up the pole, which I thought was a weird place to put it. But anyway, so I've been playing with that when I do with HF. That's what I'll go out and I'll hook that up and just see how it's doing. And it seems to work pretty good. Much better than, I mean, I like a wire, but it is true. The vertical is better. It's a little bit less noisy. And you can look this chart up. And this chart's actually on our website. You want to go to our website to find out what Russ sent you, find out what it translates to with that bottom where it says HF conditions, 80 to 40, good, 30 to 20, good, 17, good, 12, 10, good, 4. What? That's where you can go, or there's several other places you can go to the QRZ web page that's on there with a little bit more detail. But there's some stuff up there. What does it say about the SFI, the solar flux index? What? Right at the top, right? underneath the-
157.
So would you say that would be a good thing?
Yes.
Reasonably good.
Reasonably good. Now, that's the number that, remember, he said that you really wanted to go for? What's the highest that can go?
300.
300 to 400. And that's what they would call a banner day on HF, where you couldn't get on because there's so many people on there.
10 meters wide open.
10 meter,
When you make it
6
to the
meters,
nighttime.
6 meters, yeah.
Yeah.
So it would be train wreck after train wreck. The SN number's 154. Where's that good gonna sit? Same thing. Anytime it gets around 150, that's good. That's right in there. It's getting pretty close to the maximum on that number. So those are the two that we've talked about so far. Now we're going to get down to some of these other things, but as you see where it translates down, and then you look down there at the current solar image, what's those little orange dots in there?
Sunspot.
Sunspots. But you know, what side of the other? Who gets the picture of the other side of the sun?
Nobody.
So you don't know what's going on there. Can you determine how good propagation will be from the solar, based on the solar? Generally.
You have to look at the ANK though, like you're gonna get.
Yeah. So it's general. So you gotta put some more things in the puzzle to make it work. But generally speaking, yeah, if you want to find out if it's going to be pretty good, if you look at that SFI and it's in the 150s, you got a better than a 75-80% chance it's probably going to be a good HF there.
Just a quick question. Since, Ola, since you're giving us the first line, how about all the other lines? Does that mix in with it?
It mixes in with it. Yeah, there's some of them we're not even going to talk about because there's no reason to get too deep in the mud because you can only endure just a little bit of this at a time. But the key points so far are out there. Most of the time, including you can see this chart. There's others on QRZ. There's a couple of other ones. There's some actually pretty cool ones if you start looking at are new. And now there's a couple of AI generated ones. Has anybody looked at any of the AI generated? They're actually pretty interesting to look at because they do predictability based on the cycle they go back. Since they've been doing the 11-year solar cycle and take the data and put it all together and gives you a projection. However, there's one more important thing to remember. Just because the solar flux index finally went above a certain number, it doesn't automatically mean that the band will be good. There can be some outlying factors that could affect that. For example, 10 meter on mini chart shows good when the SFI is above 150. However, we're in Florida, and a contributing factor to that not necessarily being good would be the Gulf of Mexico. Now, what's interesting, Gulf of America. Oh, what? But it takes a little while for that to heat up. Now, when I got into this hobby, my queen tried to talk me into this hobby for years and years and years, and I was kicking, screaming to go away. And then finally I got into it. And when I started getting into a little bit of HF, I'm going, keep hearing the same thing. Same, not necessarily true. I know it's just the same. I kept hearing on 20 meters, if you can't talk nowhere else, you can always talk to Italy. You know why? Same thing as us. They're surrounded by salt water sitting in a radiated bed.
I thought it was because they ran 5 kilowatts.
It's in California.
So with the solar flux being up on a day SFI, it doesn't necessarily translate to that day. It can be several days down the road that you could have good radio propagation based on the solar flux of 3 days before. impact.
It takes a while for that radiation to get through the, how many million miles is it? 97 million.
The impacts of HF are pronounced on 2017, 15, 12, and 10. Now, I know some of you guys are technicians and you don't know anything about what we're talking about. You're going, what the heck is this thing about? Well, this is what they talk about at HF, and this are high frequency, which is always funny to me because it's the lowest stuff out there. But 20 meters, 17 meters, 15 meters, 12 meters, and 10 meters. 20 meters has been around a long time. 17, 15, 12, 10. 10 is 10 and 20 are the older, 20 being the oldest as far as licensed operation. One of them's just been in existence since the late 70s or early 80s. So a lot of things in ham actually evolve over time as far as nobody using the thing, and we grab the spectrum from the FCC, and then they turn around and figure out they want the spectrum for telephone transmissions and come back and try to take it away from us like they're trying to do 12. So you got to watch. That's why the ARRL is a great thing, because they're the only people that's going to act in our benefit. They're going to act in your benefit to protect this spectrum. 17, 15, and 12, a little bit harder to use. You almost have to be antenna specific to use those bands, where the 20, 40, and 10 are another one on your test. Even the technician test, what are they called? Harmonic. So they tend to work with antennas.
40 and 15 are well harmonic together.
Yeah, 40 and 15 are harmonic together as well. Lower bands 80, 40, and 30 are less affected by SFI and are more affected by geomagnetic. So geomagnetic activity is something else you will see in the morning report, and we're going to talk about that a little bit. Is there an SFI chart for how big that HF band may be based on sustained SFI? Not really. Oh, I guess there is. There's slightly variance in their charts, but the chart on the next page will give you an idea of what you can expect, and you never put that chart. Other than this. I keep pushing buttons and then I have that. So that gives you your value on the left and gives you an idea of what. So what do you do? DX on what?
I DX everywhere. Every
DX everywhere?
Yeah.
Voice or phone or
all
CW?
three modes. Digital, CW, voice.
Where CW is the most penetrating of those.
Well, it's because of bandwidth.
Yeah.
You know, so you put all that power into the most narrow bandwidth, it's going to give you the best possible. However, the technology of FT8, FT4, MXF, all the rest of those has the ability to hear even lower signal to noise ratio. So I would say at this point, FT8 actually is a little bit more sensitive than CW. Except I think I've worked some CW ESP contacts over time. Okay. You just get there where it's amazing that you made the contact. For one small minute, second you hear your call sign, and a 5.9, you're in a log. You know.
Wow. How many other people do CW? He's a CW guy. Nobody else does CW. I know Gary is an FT8 guy. Dan's an FT8 guy. Who else is an FT8 guy? What about the FT8 guys? The rest of you just voice, you don't care.
No matter how you get it.
What's your opinion? You do both. You do FT8.
I got a ZBX to do FTA, but I haven't used it yet.
Okay.
I'm gonna do voice.
Okay. There's so many lollipops that you can lick for ham radio.
That's the great thing about it.
It's an amazing hobby. If you can't find something to do, you have to look.
Plus, those of us that have been doing it for a long time, the 11-year cycle, you learn to live with what, you know, we're kind of on a double peak right now, and it's max. But I also remember a lot of solar minimums when 20 meters is not even open, you know. So it happens.
And we're peaked.
Yeah, we think we're going to have a double peak on this cycle, actually. It's kind of setting up for that. We had a double peak a couple of the last cycles, or the last 3 or 4, where there's been some measurable double peaks. Okay.
You want to tell us what that little peak is?
Well, solar,
Double peak when
yeah.
it's, go ahead.
so solar max is when you've got the peak of flux. Typically it's flux you're measuring. So 400 maybe be your peak, and then you'll see 350, 300, 200. We're at 150 right now, roughly. But that could go back up this winter for a second peak. That's what they're looking at. So you may see 200s again before it begins to go to solar minimum.
That would be on a big antenna, right?
Well, no, I mean, any kind of HF antenna. It's not, yeah, bigger antennas help, but, a regular end-fed, a vertical, it's all going to work. It all works, trust me.
And when you talk about a vertical antenna for HF, you're talking about the total antenna is probably 21, 22 foot. Yeah. So easy to put up, easy to take down.
There's bigger verticals that can help you,
Oh, yeah.
but yeah.
Guys that live in HOAs are hiding in the trees.
Yeah.
Flag poles. So, I mean, there's a lot of ways to
There's lots of ways to stealth an antenna.
Besides the sunspot number and the solar flux index, here are some other items you may see convey warning, and that's the geomagnetic storm activity. Now, this is where you get preppers looking at the hobby because they're seeing geomagnetic storm activity. And I think there's some pretty interesting things there. And this little booger right here is what attracts their attention. CME. Coronal mass ejection. Anybody have any idea what that means? That's it's the sun is spitting up stuff and it's not necessarily good.
No.
Now, Charlie's favorite word to me every Sunday is what? What effect?
Carrington.
What is that? The Carrington. Does anybody know what the Carrington effect is? Does anybody know what happened on September the 1st and 2nd of September 1859? CME, largest recorded CME in modern history. It was so bad. And you say,
How bad
is it? Trying to get somebody's head. So remember that, but no.
I don't remember that old yet.
That was
Carson.
years old.
That was Carson.
It was so bad. This was telegraph time. That it literally burnt the wires off the pole.
Those wires acted as antennas.
But what was the most interesting thing is it radiated the ground level so much right above it that they were still able to send telegraph messages with no wire.
You mean wireless?
Before wireless is cool. What? But can you imagine that? And now people are saying, and I hear people all the time, what do you do to protect your radio from a CME? What, and I tell them, nothing. If you got a CME like that, I don't think there's anything going to matter what you do to it. And the theory behind this CME is, by some people's, that's how the Earth will end. Is a CME will be so strong that it will burn us up.
Yeah.
It's just going to burn us up. So, but those things are amazing, but they play into amateur radio. And then the coronal holes in the sun. Now, if you get a chance to go on some of the YouTubes and look up some of the solar recorded coronal holes in the sun applied to the sunspots and watch them erupt, that's just cool stuff to watch, because you think about it and you're going, that's a long ways away. And then it depends on how bad it is, in either 8 to 10 hours or 8 to 10 days, you've got a problem on Earth because of that massive influx of the coronal mass ejection off of the sun, because it's radioactive. Then you get these guys, which are all part of it. You get the solar flares. And there's HF guys that say, oh man, solar flares, radio's gonna be good. Not necessarily. So what is a geomagnetic storm? When it comes off of the sun, it comes off of a solar wind like this, and we do not have an electromagnetic field. A lot of people say we have an electromagnetic field. We have a geomagnetic field. And that geomagnetic field is what protects us from that solar wind. See how but sooner or later, that solar wind sneaks through and it has a strong push, and it's firing. For the gun enthusiasts, I'll put this in perspective. It's not firing a shotgun to where it goes around from the sun. It's firing a 223. And it's going to go right straight on through. And that's where you're going to get an effect. Anybody get that analogy?
That's right, you know, Carolyn, we got to
but I think I just said that in a different way. Streams of charged particles ejected from the sun. That's what we're talking about. These storms occur when certain solar phenomena like coronal mass ejected CMEs or high-speed solar wind collide with Earth's magnetic field, geomagnetic field. And it's a collision. And it sends all kind of energy to it. Now, does anybody remember about 18 months ago, we had a CME that affected stuff? Yeah. It affected a lot of things. It affected satellite receptions for television. It affected cell phones in California. The Northern California had a huge power blackout. So it does have a tendency to affect our living on Earth here. But how does it impact radio? It disturbs certain frequencies between 3 and 30 megahertz. What sits in there?
And bands.
Mainly our HF bands that we work on for our hobby. So those are critical. It interrupts the radio wave propagation, especially during geomagnetic storm. Raises the sorry, it's in there somewhere to come back around. Sort of like a meter. But the ionosphere's density and structure are highly variable, and the signature paths can fluctuate. So where you would normally have your, and I'm going to use the wrong terms for you guys who are the truest in the HF just to get the point across, where you would have your traditional refractory hop. With this, that hop may be extended or drastically shortened, but where your predictable hop would be, Mr. Howard told me one time, he said, your first hop on 20 meters is Valdosta, Georgia. And he's about right. Because that's where your first hop is on 20 meters is southern Georgia. You get lucky, you get a little bit further out. Yeah, but your first quote hop, but this will affect that hop. Instead of that going up and coming back down, it can drag it out and then drop it down somewhere completely different. And it causes distorted propagation on HF bands like 80 and 10. Especially 80. Yeah. And you may be able to explain why. I can't.
Well, solar flutter occurs pretty much everywhere, but 20, it can be pretty announced over the pole.
So, we got to play with the sun. We got to play with a lot of things. So the maximum usable frequency will drop during this time. Increased distances will be degraded by the 45-degree latitude. Anybody know where that's at? Nope. You draw a line between about the lower third of Oregon all the way across the state lines in Montana, and just follow the state lines all the way across to southern Illinois. That's about the 45th degree latitude. So that's where that will drop it below that line. So your true hop's going to be further south. And the D layer that they're associated with the storm increases lower, especially below 20, causing radio blackouts. That's what we had about 18 months ago. We had radio blackouts. We even had radio blackouts on VHF, UHF, and we even had some as high as 800 megahertz that were affected on the video. It just depends on where they were in that fall. And that's what you were talking about, flutter, rapid signal fading, and unexpected change in propagation paths. If you ever listen to, I'll say 40 meters is probably the best example. During the daytime when it's not supposed to be good, you'll hear somebody just booming in here, and then in 38 seconds, he's gone. And right before he goes, you'll hear that that fluttered sound. So, but it's unreliable or temporarily impossible on the vector. And technicians, I mean, have you ever got to play with communications on VHF and UHF? You talk to somebody from another state. I know here a couple of months ago, we had early in the morning, I turned on my radios on VHF, and I kept hearing these two guys talk on our frequency, on the.
It's up around Pensacola.
Well, this one was not. This one was in North Carolina, and but the signal meter's just going nuts, almost full bar. I'm going, what's going on? I thought we had something wrong with the repeater, so I went over to the radio and I took the CTCSS tone off. Here I hear these two guys talking. So I put my radio on search to get the CTCSS up, and I called them just to see if
You could talk to them.
and I carried on a little bit of a conversation. So it's actually pretty cool when it affects the VHF. Now, it not only affects that in ham radio. Let me tell you a story that happened here in Polk County on low band. We're talking about the 32.06. We talked about this last meeting when I was talking about the history of Polk County radios and Polk County Highway Patrol. The term county radio still is used today for those of us in public safety. We're very familiar with the term county radio. That's the county dispatch center. It used to be the county dispatch center, which now it's all dispatch center. Well, a guy named Glenn Cundy was the dispatcher one morning on 32.06. This is obviously what was happening. And he heard, "Get me an ambulance now." He's going, and he called on the station. He says, "Where do you need an ambulance?" The guy answered him and said where he needed the ambulance. And it was the day that George Wallace was shot. And Polk County actually heard the call better than the station where the incident took place.
Wow.
So we played a kind of a small role in history on that, but I thought that's a pretty cool thing. That 5 states away or 4 states away, that we answered the call for help based on this propagation.
Well, tropo is mostly,
Yes.
tropo.
We used to call it skip.
Yep.
Yeah.
You guys call it in or no?
It'll happen on UHF too, because in the 70s, it happened, I was in Indianapolis and we were on our bell maintenance radio and we could actually hear Minneapolis, which was on the same frequency. And we could actually talk to people in Minneapolis from Indianapolis on 450.
I've got too many policies. In summary, geomagnetic storms generally cause disruptions, signal degradation, and amateur radio. That's true. Particularly the higher latitudes we talked about. And you hear that absorption and the fading that you were talking about before. An unstable propagation path. Here's a couple of graphics that are good. Coronal mass ejection CME coming off. It's a direct, like I said, it's like a 223. It's a straight arrow. It's coming at you, and there's not much you can do about it. It's on the corona, very similar to DI. So that's an hour later. So these events can send billions, that's with a B, billions of tons of solar material. Did anybody see the video of the supposed rock that fell in out of space in Atlanta?
Yeah, I saw something about
last
that.
week. Just flattened the house. Unfortunately, nobody was in it. Billions of tons of stuff out there embedded in these flying fields of space. How will they affect radios? Well, you have disruptions, and which are kind of critical for what we do. So they do just about turn your ability to communicate from point A to point B off. So that's another one where you turn the TV, turn the radio off and go watch Andy Griffith. For those who don't know, I'm an Andy Griffith. It can cause strong geomagnetic storms and ionosphere disturbances. And it sucks that what we're trying to hit in that D layer out. So that's why it's not working. It's dissipating, it's gone. And it reduces the higher frequency HF things we talked about earlier. Talked about that again. Bacon frying, the noise levels up, unpredicted changes and skip resistance. And y'all can clarify this, you guys do this all the time. NVIS, is that as affected?
Yes, because that NVIS is designed to skip off the D layer for the most part during the day. Yeah.
Now, how many of you are boys here and used to see the Army Jeeps go by down the highway? Anybody notice anything funny about their antennas on the bent? Huh? They're bent for a reason. They're always bent. Everybody thinks it so they won't tear up their garage. No, there is no problem. Those are bent that way for NVIS. If you never noticed that, even on the big trucks, the antenna's always bent back and hooked. So sometimes improving on this propagation early in the cycle, and modern as it gets stronger and weaker and weaker and weaker. Never been so lucky. You guys may have been, like I said, I don't play a lot. That's a cool picture.
Mm-hmm. Yeah.
So, had solar wind is there, and you see the jagged edges of it. By the way, that black thing's not there. He's just hiding. It's cooler. Isn't that something? Everybody thinks that the sun's the raw holes are hot. They're not. They're cooler, and it causes a disruption. These holes are caused by regions where the sun's magnetic field lines open into space rather than looping back to the sun. So it goes out. Has no place to go. How do they affect us? Well, they alter the ionosphere and they increase the streams. HF frequencies tend to change, and I'm trying to remember what the guy said, how they change, how you would know you're messing with this. Remember? I remember the guy, I heard him today talking about it. That's how you know you're dealing with a geomagnetic storm listening to your radio. It's radio wave propagation does something.
I think the noise floor comes
Yeah, noise floor comes up and you just don't. Yeah. Yeah.
So, anyway, I'm sorry, I'm losing my mind. That's another cool shot. Wouldn't want to be there, but that's cool. No. It's not a beach you want to go lay on.
You don't want to be in the ISS when it's
Sudden intense burst of radiation from the sun's atmosphere caused by a release of magnetic energy. Bright, localized flashes and release of electromagnetic energy. Now, these things are captured in the United States by 8 specialized telescopes. And they send the data, obviously, to each other, and they analyze that data to determine where the solar flares are and how much they're going to impact. And one of them is at 9,500 feet out west, just outside of the one of the Air Force bases. Anyway, if you ever get a chance to go and look on YouTube, there's a guy who got permission to send his drone up. as long as he stayed behind the lenses. So he stayed behind the lenses and got some pretty good shots. Pretty good. They disrupt HF, typically 1 to 30 minutes. We're just in all kind of trouble. Everything affects what we do, especially between 1 and 30 megahertz, used by many amateurs. I think it's fun. All the HF stuff we want to 30 megahertz. Radiation ionization of the Earth's atmosphere, especially on the new air, which means it'll only have to win.
Daytime.
Daytime. Radio blackout again, or signals fade, or disappear completely, especially on HF bands such as 40 meters and below. So, there's a picture of that. Anyway, we'll look at this real quick. M class or X class system used in 1970. Why do you think they started in the layers at D? Just real quick.
Well, a lot of military traffic utilizes the D layer in the daytime.
Well, why did they call it the D layer? D, E, and daylight.
I don't know. Daylight makes sense, but somebody came up with the layers when they discovered the ionosphere.
When they did this and they started basing this, they were not given access to some military information. And they discovered that the military uses A, B, and C for similar things. So they started with D. The label is D. Oh, that was pretty interesting. And the intensity are A, B, C, M, and X. And he going to list 2 of those. Each class represents 10-fold increase in X. So the M class is 10 times stronger than a C class. So when it gets up to an M class, that's where you have problems like we have before. That's where you start having almost no keep on. But those are some of the things that are A class, we never see it. B class, no. C class, those are very few. M class, minor radio blackouts. X class, telephone lines. It's a big thing. So
And Aurora.
and Aurora, thank you. And I was gonna say, and you make my wife happy when those X class comes up, and make me get up at 3 o'clock in the morning and drive her out Highway 60 where there's no lights. Because last year 3 times the Aurora was visible in Central Florida, as far south as Fort Myers.
Wow.
So, and there's only been during this 1859 thing. This is another thing here. When that occurred, you could see auroras in 100% of the world that was inhabited. They don't know about the Antarctica because nobody was there, but they were seen as clear as day as far as middle of Africa and down in Australia. It's cool. You've never watched this lady right here. She's a space weather nut. And she can explain stuff, so you got to go look up. But she is very good. And Tamitha Scott is her name. She has a YouTube channel. And she gives great stuff on weather. There's your youtube.com. Tamitha Scott.
Yeah, you circle down to your right.
I think we're running out of time here.
All the way down home.
Anyway,
Press the copy machine.
Eric, we continue to explain Russ's signal message every morning.
Can you put that slide deck on the website where people could look at it later?
Which one?
This whole slide deck.
Yeah. We'll put the whole thing on there.
How do you subscribe to the signal?
Okay. Do we have a signal master here?
I think it's John and
Are you a signal?
I'm not authorized, no.
Okay.
I think it's only John.
Are you
John and
signals? Are you familiar with Signal?
No, I've never seen that.
Okay, for those of you who are not familiar with Signal, Signal is an encrypted messaging service.
Oh, okay, the app. Okay.
We
got it.
have used it.
That's the one that got Hick stuff in trouble.
Yeah. I thought it was a newsletter. I'm sorry.
We use that bites.
Okay.
We use that as a messaging tool. It is just unbelievable. What's good about it is, I won't use him as an example. If he asks a question about something, this is on the Lake Wells Signal site. If he asks a question something about his station, he can't figure out how to do something, I guarantee you, within 5 minutes, 5 people have answered him on how to help him. It's a helping tool that this club has used. We also have another signal that allows you to sell radio equipment by advertising. The average stay on that site is 5 days. So I mean, it's sometimes a lot. Yeah, sometimes a lot. It's a good medium to use, but we are very active with it now. We kind of get loose sometimes, and sometimes we don't know. Some people don't know what time people go to bed at night. So you may have to turn the alarm off. But if you want to be on Signal, Russ or John, get the app and send it to. Get that on the phone. I'll give you my phone number after it, and I'll get Russ to get you on, or John. Because it goes by, you just have to tell me what your name
I'm
is.
downloading it right now. I had it before, but I took it off.
You just have to tell me what name you're going to call yourself. Most people call themselves by their call sign.
Yeah, that's right.
Name and call.
All right. It's like fishing. You don't know what you're going to get if you don't go out there and try. That's what I said earlier. You don't know who's on the radio unless you try it. You can do it. Anybody have any questions? Thank you for not bringing rotten tomatoes or fruit. So much appreciated.
I am in the car. Very brave.
Russ will edit this and he'll drop these slides into the video that'll be on YouTube.
Okay. And Russ may put this on his Spurious Editions on. So if you don't know, Russ has a website called Spurious Editions. Get a lot of information. So anyway, Harry Island Park on the last day of the month. Big Dogs on the Porch will be there. How many of you don't know what Big Dogs on the Porch is? Ooh, it's food. We have brats, hot dogs, and burgers at the end of the QRP. So
Where is it this month?
it will be at Mary Holland Park. You know anything about Bartow?
No, but I'm learning the area, so I'll be able to find it.
You take 98 south in downtown Bartow, you keep going south, you can't go nowhere but Mary Holland Park. It runs dead end. We have a good time. No other questions? Unless motion to adjourn?
I'm going to,